Today we'll talk about standard form and graphing special lines and intercepts, or graphing with intercepts, plural, as opposed to slope-intercept form. First, we want to discuss standard form. So on your Cornell note sheet, find where standard form is. Down here. Standard form is a special way that a linear equation can be written. And there's four things that we know about standard form. Number one, it's got to be in the order ax plus by equals c. So the x and the y must be on the left side of the equal sign, and the constant or the whole number needs to be on the right side. And the x and y have to be in this order. So it's not just they have to be on the left side, but the x must come first and the y must come second. The second thing that's important about standard form is that there are no fractions in standard form. So A, B, and C, these numbers, must be whole numbers or integers. So A, B, and C must be integers. Sometimes the book will say that. A, B, and C must be integers. All integers, which remember are whole numbers. Number three, once you get it in this order and you've gotten rid of all the fractions, you need to check that A must be positive. A must be positive. A cannot be negative. And finally, number four, it must be in simplest form. So, for example, I think we can understand the order and the fact that we need to get rid of the fractions. A must be positive. We can divide everything by a negative number if we want to get rid of the negative in front of an A. But simplest form, I need to give you an example of that. If we had done all of this work and we had 5x plus 10y equals 15, and you look at that and you can see that all of these coefficients can be divided equally by 5, then you can't leave it like this. This is not considered simplest form. Now, we have to go through and divide every single piece by the same number if we want to simplify it, and that would give us x plus 2y equals 3. And now this is in simplest form. The a is positive, the x comes first, the y comes second, and there's a constant on the right side of the equal sign. So using these four rules, we are going to work on these first examples here. It says, write each linear equation in standard form. If it can't be written in standard form, say it's not linear. So in number one, what is wrong with number one? It's in the wrong order. So this x that's on the right side of the equal sign needs to be moved to the left side by adding 2x to both sides. We just need to move it all the way to the other side. And remember, when you write these down, the x must come first. 2x plus y equals 5. So it's in the right order, number one. It has no fractions, number two. It's in simplest form because we can't divide them all by the same number. Every single piece has to be divisible by the same number to simplify it. And the final thing, A is not negative. So there's your standard form there. Number two, we see that there's an x next to this y here. Could we get rid of that y? Well, we could divide this whole side by y, but we'd have to divide this side by y, which would then put a y on the bottom of the 6, which should give us a fraction. There's actually no way to get rid of that y because this is not a linear equation. So as soon as you see some funkiness, it's probably because it's not a linear equation. Number three, it seems to be missing something. Yes, it's missing a y. But that is okay. It's okay to be missing one of the pieces, it just can't be in the wrong place. So we know the x should be on the left side, and this constant should be on the right side. So what we can do is just flip the whole thing over, put the 3x on the left side, and put the negative 15 on the right side. Okay? And that's just the symmetric property, just flip it over. Next thing we need to do is, it's okay if we write this and we include a y also. What would that y be? 3x plus how many y's? 0y equals negative 15. 3x plus 0y equals negative 15. So that's can give you you can see why it's okay to be missing a piece. It just can't have an extra piece. Now there's one final thing we need to do here. All of these are divisible by 3. So we need to divide each piece by 3 so we can simplify it. We get x plus, it's still 0y, equals negative 5. X plus 0y equals negative 5. And now it's in the right order. The number in front of x is 1, so it's positive. There's no fractions, and we've gotten it into simplest form. We'll do one more together, and then I'll have you do 5 and 6. Actually, let's do 6 together, and then you can try 4 and 5 on your own. So 6, you can see we have a fraction, 2/3. I apologize for that. If you want to rewrite it 2/3, that's fine. But we have a denominator of 3, and we also have a denominator of 4. So we have talked about what to do with those fractions. You want to multiply through by the common denominator. So imagine if you were adding 2/3 plus 1/4. What would that common denominator be? It would be 12. So we want to multiply every single piece by 12. Multiply by 12 over 1, multiply by 12, multiply by 12 over 1. So the easy piece is 12 times x, which is 12x, minus 1/4 of 12, which is just going to be 3y. 1/4 of 12. So you could simplify this. 4 goes into 12 3 times. We get 3y. And then 2/3 times 12 over 1. So if we do 12 over 1 times 2 over 3, 3 goes into 12 4 times, and then 4 times 2 will give us 8. So when we multiply through by the common denominator, which in this case is 12, we've gotten rid of all of the fractions. 8 equals 12x minus 3y. And we need to put it in the right order. Now the x and the y are on the right side. They can't be on the right side. They have to be on the left side. And this constant has to be on the right side. So you can just simply flip the whole equation over. So we get 12x minus 3y equals 8. No fractions. Our x and y are in order on the left side, our constants on the right side, and there is no single number we can divide every single piece by that would make this come out even. So we can't divide by 3 because it won't work here on the 8, and we can't divide by 2 because it won't work here on the 3. So this is your final answer, 12x minus 3y equals 8. Now push pause here, please, and try number 4 and number 5 on your own. So let's look at number 4. Probably the most obvious thing to you is the fraction. So it might be best to get rid of the fraction first. You can do other things first, but most of you may have gotten rid of the fraction first. So we multiply through by the common denominator, which in this case is the only denominator, which is 3. Multiply by 3 over 1. On the right side, we get negative 1 times 3 is negative 3, and x times 3 is 3x. On the left side, 3 over 1 times 1/3, those are going to cancel out completely, and you're left with just a y. So we've gotten rid of the fractions, but it's in the wrong order. We've got to move that 3x over to the left side. So it's a positive 3x, so we're going to subtract 3x. So we get negative 3x plus y equals negative 3. Are we done? No, we still have one small problem, and that's that a is negative. We need to get rid of this negative. So there are a couple ways you can think of this. To get rid of just this negative, we could divide everything by negative 1. And what will happen when we divide everything by negative 1? The signs will all just flip. So we get 3x minus y equals positive 3. So you can show that you're dividing everything by negative 1, or you can just flip all the signs if you want to take that shortcut. That's fine with me. How about number 5? Very similar to number 4. We want to get rid of that fraction first. So we multiply everything by 5. I'll just use this 5 as my 5. So 5 times y is 5y, minus 7 times 5, which is 35. 5 over 1 times 1/5, the 5's will cancel, the 1's will cancel, and you'll be left with just x. Now we need to look at our order here. the y is in the wrong place. It's got to be on the left side. So we want to move the 5y over, so we subtract 5y from both sides. And we get x comes down first, minus 5y equals negative 35. We've got it in the right order. X and y are in alphabetical order. The constant's on the right side. A is not negative because A is positive 1. No fractions. And we can't divide all of these by 5 because this 1 cannot be divided by 5. We'd be getting a fraction. So there's your final answer. So that's standard form. You want to make sure that you have memorized the 4 rules for standard form so that as we move through the chapter, those will come easily to you. The second piece of this section, graphing equations that only have one variable. So if you imagine we get an equation that's y equals 5. If we use a table like we did in section 4.4, we can use the same values for the domain or the x values, negative 1, 0, 1, and 2. And you see there's no x in this equation. So this is what it's really saying. I don't care what x is, y equals 5. So if x is negative 1, y equals 5. If x is 0, y equals 5. If x is 1, y equals 5. If x is 2, y equals 5. This says y equals 5. Y is 5. No matter what, y is 5. So let's plot these points and see what happens. Negative 1, 1, 2, 3, 4, 5. 0, 5. 1, 5. 2, 5. What kind of line are we getting here? A horizontal line. A horizontal line. Okay. What about if x equals negative 3? Now this is going to be tricky when we make the table because instead of putting values in for x, we're going to put values in for y. Negative 1, 0, 1, and 2. And this time it says, I don't care what y is, x equals negative 3. So x is negative 3, x is negative 3, x is negative 3, x is negative 3. And go ahead and plot those points. Negative 3, negative 1. Negative 3, 0. Negative 3, positive 1. Negative, oh, I didn't go back far enough. Negative 3, negative 1. Negative 3, 0. Negative 3, 1. And so this time we get a vertical line. So here's what we get. And we're going to go ahead and write this on your Cornell note sheet. When you're graphing equations with one variable, well, we're going to flip it over to the back side, and if it's not already on your sheet, you can add it to the bottom. Graphing equations with one variable. Okay? So when you graph an equation with one variable, the first thing you want to do is solve for that variable. So for instance, if you had an equation 5x equals 10, and you see there's only one variable, you want to solve for that variable. So divide both sides by 5 and you get x equals 2. Now, once we have it solved, this is what we can understand here. Anytime you have a y equals, it's always going to be a horizontal line. So if y equals 5, that's going to give us horizontal. If x equals negative 3, that gives us a vertical line. And we will see this trend throughout all of these problems. Okay? If you have, we're going to graph it then, second step. If x equals something, it's always vertical. And if y equals something, it's always horizontal. And I have a little cheesy piece to help you remember this. If you have x equals, imagine a V sliding down in the top there, that's always going to tell you it's vertical. If you have y equals, imagine flipping that y upside down. It looks like a funky H for horizontal. So if that helps you, what we don't want to do is continue making tables for all of these. So this is another piece that you need to memorize. If it's an x equals, it's a vertical line. That means it goes up and down. If it's a y equals, flip that y upside down, it's a horizontal line like the horizon, the sun comes up on the horizon, which goes horizontal like this. You like my sun. Okay? So let's go back and take that quick route for these last three problems. Draw a quick sketch of each line. So y equals -2. Look at that y. Flip that y upside down, it tells you it's horizontal. So all you do is find where y equals -2. This is the x-axis, this is the y-axis. Find where y equals -2 and draw a horizontal line through it. Like that. Okay? If x equals 5.5, think the v that you can slide down into the top of that. And so we know x equals 5.5. Find where x equals 1, 2, 3, 4, 5.5. And you just draw a vertical line through it. No tables anymore for these. Oops. No tables for these at all. Okay, you need to memorize x equals a vertical, y equals a horizontal. So in number 3, I see right away there's only one variable, it's y. I have to get that y alone. So we subtract 6 first. We get 2y equals 2. Divide everything by 2. Sorry, I'm squishing a little. And we get y equals 1. Y equals, flip it upside down, gives us a horizontal line. So on the y-axis, find where y equals 1 and draw a horizontal line through it. Okay? X equals vertical, y equals horizontal. Again, like this. The v slides into the x, makes it a vertical line, goes up and down. Y equals, flip that y upside down, it's horizontal, it goes left to right, like this. Okay? That's the second piece in today's notes. The last piece is graphing with x-intercepts and y-intercepts. When you graph with x-intercepts and y-intercepts, there's a couple steps that we want to go through, but let's first do a problem and then we'll go back and fill in our x-intercept and our y-intercept. So we have an equation here, 3x plus 2y equals 9. Now we want to find where it crosses the x-axis and where it crosses the y-axis. And if we want to do that, in this case, this is already in standard form, which is going to be very helpful for us. I'm going to go the long way on the first one, and then I'll show you the shortcut also. So once this is in standard form, basically, if we want to know where it crosses the x-axis, y would have to be 0 here. If we want to know where it crosses the x-axis, because it's not going to go up or down. So if the line were here, then the y piece of that would have to be 0 if it's sitting on the x-axis. So the first thing we want to do is plug in y equals 0 into this equation. So we get 3x plus 2 times 0 equals 9. 2 times 0 is going to make this drop out completely. So we get 3x equals 9, and we divide both sides by 3, and we get x equals 3. So what this is telling us is that we have a point where x equals 3 and y equals 0. 3, 0. And that's where the line is going to intercept or intersect the x-axis. So let's actually fill in the definition of an intercept first. I'm getting ahead of myself here. So underneath standard form it says x-intercept and y-intercept. The x-intercept, think of the word intercept. It sounds a lot like intersects or intersect. It is where a line crosses the x-axis. And again, imagine if a line is crossing the x-axis at a point. That point's going to have to be some number and 0 for y. So plug in y equals 0. So it's going to be some point, something 0, some number 0. Now the y-intercept is exactly the same but flip-flopped, where a line crosses the y-axis. So instead of plugging in y equals 0, you plug in x equals 0. So you'll have 0 and some number, because if you have a line that crosses the y-axis here, this point has to be nowhere on the x-axis, so it's going to be 0, and then somewhere up and down on the y-axis, and then it's a number. So when we graph a line with y-intercepts, the first thing we want to do is put it in standard form. This is going to make it easier for us to work through this, which is ax plus by equals c. Now when I say standard form, I kind of mean a relaxed standard form. You want to get rid of your fractions and then get it in the right order. So fractions in the right order. You don't have to do all 4 of the standard form steps, just the top 2 basically. Okay, once you do that, then we'll continue on. Now let me finish showing you the long way, and then I'll come back and show you the short way. So I plugged in y equals 0, and I got this point 3, 0. That's going to be our x-intercept. Now to find the y-intercept, we plug in x equals 0. So start again from the beginning. 3 times 0 plus 2y equals 9. 3 times 0 will be 0, so that whole thing will drop out. Divide both sides by 2, and we get y equals 4.5. So on the y-axis we find 1, 2, 3, 4.5. And now we can sketch this line with just these 2 points, because this point was 0, 4.5. We plugged in x equals 0, so that's our x value, and it gave us y equals 4.5. And you can connect these two, and that gives us our line. So instead of making a table, you find your intercepts, and you can plot the points and draw your line. Now some of you probably think this is longer than if we were to just make a full-fledged table. Now let me show you, we would have to solve this for y if we were going to make a table. But there is a shortcut that we can do, and that's making a mini table. Now we're only looking for 2 points in a mini table. We're looking for when the x equals 0, and we're looking for when the y equals 0. And here's the shortcut. So once we put it in standard form, then if I know x equals 0, what we could do, look at the original problem, that's going to make that whole thing drop out. So you can just cover it with your finger, and you get 2y equals 9. And in your head, if you want, you can divide both sides by 2, and that's where the 4.5 comes from. So if it's in standard form, you don't really have to show any of this work down here if you want to just cover it with your finger and solve for y. Now when I go to do y equals 0, when I plug in y equals 0, that one's going to drop out, so I'm left with 3x equals 9. So in my mind I'm saying I'm going to divide both sides by 3, and that gives me x equals 3. So in the x column I get x equals 3. And then these are your 2 points, 3, 0, and 0, 4.5, and you plot them. Okay? So if we complete our Cornell note sheet, you can take this shortcut. Number 1, put it in standard form. Number 2, make a mini table. And let's just remind you what the mini table looks like. X is 0, y is 0, and you're just figuring out where these are. And then, of course, you're going to graph it. Graph the 2 points and the line. Okay? So let's try number 2. Now you can see in number 2 it's not in standard form. So we want to get this in standard form first. And what's in the wrong place is this 3y. So we're going to subtract 3y from both sides. And we get 4x minus 3y equals 12. Right? So standard form is your first step. Once it's in standard form, just make your mini table. X is 0, y is 0. Now if x equals 0, that means this whole term will drop out and we get negative 3y equals 12. Divide both sides by negative 3. So 12 divided by negative 3 would give us negative 4. So I get y equals negative 4. So in the y column, you put negative 4. When y equals 0, we cover this over and we get 4x equals 12. So I know I need to divide both sides by 4. And 12 divided by 4 is going to give me 3. So x equals 3. So in the x column, I put 3. So one mistake I see commonly is that I get x equals 3 and someone puts a 3 in the y column. So if you're solving for x, make sure it goes in the x column. And that's all the work that you have to show. Put it in standard form and then create your mini table. So we get the point 1, 2, 3, 0, and 0, negative 4, and you're done. Okay? I want you to try number 3 and number 4 on your own, please, before you watch the rest of the video to see if you did them correctly. You really need to try these on your own before you move on. Go ahead and push pause here. I trust that you have tried these on your own. Let's see how you did. So we've got to put it in standard form first, which means this 2x needs to be moved. Now this is relaxed standard form, so it's okay that this is negative. We get negative 2x plus y equals 8. That's okay. We don't have any fractions, so that's the thing. Put it in the right order and get rid of any fractions. Now make your mini table. X is 0, y is 0. When x is 0, I put my finger over the x and I get y equals 8. Y equals 8. And we're done with that one. If y equals 0, I cover the y and I get negative 2x equals 8. So I divide both sides by negative 2. 8 divided by negative 2 would give me negative 4. So we plot it. 0, 8 is actually this point here, and negative 1, 2, 3, 4, negative 4, 0 is here. And you draw the line. Now if you did that right, give me a check. If you did not do it right, put an X next to whatever piece you got wrong. Now there is one thing I want to tell you. It doesn't matter if you make the X 0 first or you make the Y 0 first. It doesn't matter. As long as one point has an X that's 0 and one point has a Y that's 0. So remember, these are points. And then you plot those points over here. So these two go together. Last one, number 4. If you have not tried number 4, please try number 4 on your own. So when we look at number 4, we can see that the x is in the wrong place, so we want to move the 2x over by subtracting it. So we get negative 2x plus 3y equals negative 8. Again, it's okay that this is negative. We just need to get rid of our fractions and get it in the right order. Draw your mini table. X is 0, y is 0, or flip them, it doesn't matter. When x is equal to 0, we cover it, and we get 3y equals negative 8. Now, if I divide both sides by 3, I get negative 8 over 3. So I'm going to write this in negative 8 over 3, but in order to graph that, you'd have to change that to a mixed number anyways, which is going to give us negative 2 and 2/3. So you can write negative 8 over 3 here if you want, but eventually you'll have to know that it's this mixed number to plot it. If y equals 0, we cover that one, and we get 2x equals negative 8. I'm sorry, negative 2x equals negative 8. Divide both sides by negative 2. Divide this by negative 2, and we get x equals 4. So we plot these. 0, negative 1, 2, and 2/3 right here. And 4, 0, 1, 2, 3, 4, 0. Go ahead and sketch your line. Again, if you got this one completely right on your own, give yourself a check. If you miss this point, put an X next to it. If you miss this point, put an X next to it. Or let's say you got this all right and you graphed it wrong, then put an X next to the graph. Just so that tomorrow if I ask you, you know what it was that you did wrong here. The last one is just to check to see if you recall this skill. So I'd like you to do this last problem on your own, and we will check that in class tomorrow when you come to class tomorrow. So go ahead and complete this. I will check that you have your notes done, including this problem, tomorrow.